welcome to the stream. Since I didn't do Voxel Friday last week, I decided I would do it today. I don't know how long this stream is going to go. I've only slept like an hour or two last night, so I might suddenly get tired and bail, or it might be a normal stream. I just don't know. But I'm looking for feedback that this is all working right. I have my Twitch stream up, so it does look like it's working right. Let's get the window set up correctly. Ding, 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 ding. Okay. So we want to switch to ZMC2. So I believe in the last stream we went over this discussion, ideas for using more than 32 textures, and the issue that I mentioned is that a lot of these cannot support the update texture command, where the idea of this command is that we specify only like the texture on certain faces. And my thought was that, like, you know, you'd lay out a building by doing the exterior walls and the interior walls and the floor and the ceiling, and then you put down some furniture, and then maybe you want to decorate the walls by like putting in individual isolated voxels. And it would be nice to be able to do that by just saying, well, on this wall, make it this texture without worrying about what was on all the other sides. So that's the reason for the update texture command, is to do this partial update without needing to know what all the other textures should be. But if we have to support that, not only can we not use most of these packing strategies, but it's also unclear how we can do a lot of strategies for detecting during meshing, for detecting which textures to apply. We can't use strategies that unpack that command list data into memory, building a big table of all the textures, you know, like the conceptually the 2v6 by 2v6 by 1024 32-bit numbers, because we currently are packing textures into 32-bit. If you write those out, we can imagine that a step in the process blasts all those out, even though lots of them aren't going to get used. But because they're write only, we don't introduce any latency. We just use up bandwidth. And then later we can come back and read them back, and we're only reading the ones that are actually getting converted to meshes, which is a tiny fraction. But most of these methods, update texture requires a read, modify, write process. You'd have to load in even just the basic one that we have right now, the 32-bit number that's 5 bits with 6 faces. You'd have to, if you only wanted to update one face, you'd have to read that in, update the face, and write it back out. And I'm assuming that that latency would be unacceptable. So that would mean that the only strategy that would really work would be to rescan the whole command list when the step that says what textures should I actually use when I'm meshing. That step would have to rescan the command list, or scan the, like currently we do it all in one step. So that's where we left things. And I was, at the time, I was like, I don't think we can get by without update texture, so I'm not sure what to do. I guess we just have to go with that approach. And now I'm thinking maybe we drop update texture and we say that the building generator, if it wants to put a special single voxel face in a particular spot in a room, has to know what all the other faces need to be. It has to say, this is an outside wall. I want to put up a single blob, a single dot here on this wall. I know that this is an outside wall and that the outside texture is blank, and set that all up correctly. I think if we do that, that puts extra work on the CPU, but the CPU can afford it, and it's opens up the possibility of multiple different strategies for that step of the command list processing, and I think that's probably worth that trade-off, to have the option to do that command list processing differently. So that's the plan, is to think about that, to look at that, to maybe work out the structure of how most of the ways of doing the meshing is going to work as a multi-step process. Maybe we can sort of formalize it. I'll explain what I mean by that in a second. And I need to add debugging. We need to know, like, why are the command lists not getting filtered properly, and or are the command lists getting filtered? Like, why is it not a speed up to filter the command lists? So I think the first thing we'll do is we'll add debugging and profiling the GPU. But before we do that, I'm going to get food, which is in the microwave waiting for me at the moment. Now, I mentioned in previous streams that it seems weird to me to eat on stream, and everybody was like, nah, streamers do it all the time, don't worry about it. But I was just like, I don't know, it seems odd. Like, I don't know, like showing your feet. It just seems not uncouth, just inappropriate. But I'm thinking the compromise is that on this setting I can eat. I won't eat on face cam only, the close-up. But maybe this is small enough, I feel okay. Yeah, I'm not too worried about the ASMR of it. It's actually the visuals. Oh, you did say turn off mic, yeah. I think the problem is that when it's just face cam, it centers the eating as if the eating was the point. Yeah, this is the project here. Why am I not using an API like Vulkan? Well, Vulkan in particular, at least for graphics, is way more cumbersome. There's a lot of initialization you have to do manually. It uses a bad API involving linked lists. It just feels really clumsy. I've never even tried to write the code. I've just looked at other people's code and gone, this seems like lots of busy work. And OpenGL, I already know how to use it. It still works. Windows is going to continue to support it forever because Windows supports everything forever. So, no reason not to. They may not get as much attention for the drivers, but as long as they keep the basics working, the drivers probably share the GLSL code with Vulkan, so the shaders will probably always be as performant in OpenGL as in Vulkan. Maybe not. Maybe there's some difference, but as far as I know. You will see a lot of, I already know how to use this, so I'm not learning something new on this stream. You could argue that that's why I use VC6. I have the bottom edge wrong. Let's fix that. The top edge is wrong too. Why is the top edge wrong? Oh, no, it's just not zoomed out on my OBS. Yeah, okay. So the bottom edge was correct. I had a wrong view of it. Dun, 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 dun. I will probably work on the STB libraries on the stream at some point. I just haven't got myself into the mindset for it yet. Let's ask you all a question while I'm eating. Yeah. Oh, we'd asked that one. Dang it. I'm out of questions. We asked that last time. Okay, here you go. What is your favorite data structure? If you're a programmer. If you're not, sorry. Mentioned writing a book on OpenGL. Well, what I was actually thinking was like write a game engine in OpenGL was the book I was thinking about writing. So it was not like a general OpenGL book, but just a like, because people often ask that. There's like, how do I start writing a game? Like where? And so I was just thinking, I'll just walk you through making an engine, meaning a game, but just the core part of the game. Not core part of the game, core part of the graphics and world and whatever. I'm not seeing a lot of answers to my question. Okay, there they are. Maybe I have bad lag, right? Latency right now. I guess maybe we don't have that many people on Twitch. Nothing shoe. Oh, we just hit 100, so it's not too bad. Yeah. No, stop giving, Charlotte, stop giving multiple answers. You get one. So yeah, a lot of people just saying simple arrays or dynamic arrays, which we can count as the same thing. They're just arrays. Hash tables are the second place. I mean, we're pretty short. I like linked lists, says somebody. I love using a stack of any kind. So that gets at a subtlety of this question, which is sometimes data structures and algorithms are linked very tightly. Like you might have a data structure that only exists because it's used for a particular algorithm. And so like using a stack can often implies there's some kind of algorithm going on that needs a stack, as opposed to a stack being a general data structure the way a hash table or an array is. And so that was sort of a subtle thing I thought about when I asked that question, is like, to what extent are people just going to pick the generic, a hash table is essentially implementing a dictionary, and the array is implementing the array. I guess the way to put that is that the array is implementing the computer architecture's natural there's probably a specific word that I'm looking for. The idea that you're working with the grain of the underlying medium. Right, so the array is the thing that gives you order one, true order one act, not like hash table order one, but like true direct order one true direct order one access, like the computer architecture can do with memory addresses. So arrays are like a light wrapper around memory addresses in some sense. My turn to answer the question. Well, like I just said, it's kind of a trick question in that I wanted to see how people thought about it. Oh, and somebody did say B-trees. I think that covered everything anyone said. So yeah, I mean, STBDS implements the dynamic array and the hash table because those are the workhorses for getting stuff done in my experience. That experience came from using stb.h, which supplies both hash tables and dynamic arrays, but in a slightly different version. And I took that learning and made STBDS. But if I'd asked what's your favorite algorithm, you might have come up with something very different, and that could have incorporated something. So like graph is a data structure, but it's not a data structure that you'd answer that way. Whereas, if you said, oh, like building a deterministic finite automaton or using a deterministic finite automaton, like naturally those involve using graphs. and you couldn't really do them without graphs. So it's like a weird. It's just a weird and interesting subtlety of like you kind of always want to ask, what's your favorite algorithm plus data structure, you know, and to reference that title, that book title. So yeah, I probably, if you had asked me that question without context, I don't think I would have said hash tables or dynamic arrays, because I would think of those as too boring, and I would try to think of a fun one. But I don't know what fun ones I actually use. The one that sticks in mind that I don't use and would never recommend anyone use are skip lists, which are one of the most modern of the classic data structures. That never quite penetrated into common use, I think with good reason, and I don't know if people even learn about them anymore. But they're kind of a fun randomness-based data structure. There's a lot of algorithms that use randomness, so it's kind of fun to see a data structure that uses randomness. But I wouldn't answer that. Like, I'm just kind of setting that up as like talking about the concept. Yeah, and obviously trees, all sorts of possibilities with trees. I've talked before about how quad trees are nice in theory, but you almost always want a two-level data structure instead. BSP trees are fun for computer graphics people, but we don't really need them anymore very much. Sorting transparency is the only real reason. I don't know what an SVDAG is. Sparse vertex? No. Corrected acyclic graph. Oh, Voxel. So that's like instancing sub-regions of the voxel data in different places. So if it's not trees, it's not skip lists, you run into the problem that I don't actually use it, then it's like really hard to actually name it. Let me read what my exact phrasing was. Not that it really matters, but I can't read what my exact phrasing was because it was spoken out loud on stream. Oh no, I did write it down. It's in here. What is your favorite data structure? I made promised, I think, a weekend. Maybe a week of polishing, of like getting playtests and tweaking it. What is your favorite data structure? I mean, maybe I have to say hash table, because there's a lot of interesting theory to hash tables, despite it also just being a workhorse. There is a lot of interesting theory. there's a lot of way to implement how you handle collisions. There's things like cuckoo hashing and Robin Hood hashing. So maybe I do go with hash table after all. I don't have very good random access to things like that in my head. They come up contextually instead of coming up when I just am trying to think of things of the category. So let's see, OpenGL wiki buffer. Okay, here we go. So we want to be able to read back from a debug buffer. Setting flags to 0. Interesting. I don't think I'm doing that. Yeah, I don't think I want to go with mapping, so I'll just use get buffer subdata. All right. What does printf in a shader do? How do you output 10 million messages to the console? Or how do you read 10 million? Yeah, but I'm not going to know in advance what pixels. Like, the more useful thing in my experience, I mean, I don't know. I don't have experience with printf and shaders. So, first of all, I could emulate that. And I don't feel any instinct to emulate it. But I could use this exact same debug buffer that I'm about to make to implement something like that. But in my experience, it's almost, I mean, I guess if you like clicked on the thing and it used that mouse pointer position to decide which pixel should print, maybe that would work okay. But my experience, I just want to dump a big grid to memory. My experience, which doesn't include actually trying that, but I found it generally fine to be able to dump a big debug chunk to memory and then grovel through that, search it, be able to search it from code, rather than trying to predict in advance which one do I want to print. Right, I can print them all to memory, dump them all to memory, and then search and say what's the largest and the smallest, or something like that. I'm going to clean up my food. I'll be right back. Okay, so GL buffers. So create buffer texture, create shader storage. Yeah, we do actually create with 0. Wait, is it GL buffer storage that takes that? Flags field. Yeah. So in fact, we are creating by default everything with flags of 0. So, but it said 0 means it just lives on the GPU and you're not messing with it. But we don't want to map the read. We'd like to just use, without this flag of attempting to fail, map coherent, client storage. I think we can still just use 0 and get buffer subdata from it. So why is this? Oh, weird glitch. So we go to main, Boolean debug buffer. Create shader storage. And then command this color. So then we say these were typos, actually. And putting an explicit size caused it to slow down, so we won't put an explicit size. And we say data of this. say gl read buffer data. Is that what it's called? Where do we specify the usage? Wait, GL buffer storage. We just said GL buffer storage takes these. Yeah, takes flags. So where does usage come in? Oh, maybe we can't use buffer storage? To create mutable storage for a buffer object. Immutable storage. I can't tell whether the way this is the way a lot of this is written implies that you can read from it even though it's immutable. But it might be intending to say that you have to use mutable to do that. I'm not sure. What was reading? Well, we'll see. You'll get buffer sub data. And I probably have never done this before, so we need to add it. Dink, 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 dink. Buffer sub data. Oh, no, I do have it. GL get buffer sub data. It just isn't autocomplete. GL shader storage. Buffer. So we have to GL bind buffer debug buffer offset 0 size 1 to 16 data, debug data. Debug data of 1/16 over size of debug data of 0. Wonder if it lets me do that actually. No, it doesn't. That's not defined, okay. $4,000. Wow, that's a nice round number. Weird. Barrier bits. Oh, that's why it's a round number, because it's a bit pattern, not an enum. And then we dispatch it. Yeah. Okay. So then just run it to here. Okay. So first of all, right, we don't have to set the breakpoint anymore. We enabled it so it's always on. Can we just do that? Stupid. There's only 1,000 entries, so we cast it to uint. And then we say 1,000 on them. All zeros, so I did something wrong. Break there. Set next statement. Still nothing. Okay, so either we're doing this wrong, or we're not binding the buffer correctly, or we're not setting the values in it correctly. Is 31 valid? Why am I not auto-completing to it? Or not auto-completing, control tabbing to it. There we go. 15. Oh, because why did I not get an error when I tried to bind them both to the same slot? Yeah, weird. You would think that would be an error. Still didn't work. let's do this inside the loop. So it definitely has time to resolve. But maybe it doesn't work with immutable data. Like maybe that is the issue. If I'm not mistaken, overlap binding points is a way to do views, to look at a texture as a buffer or something. Yeah, maybe that's true. Maybe that was a way of aliasing the data. And then okay, maybe you can't do it with immutable. So we take our geobuffers and we'll do it locally. And then we say GL buffer data. Not subdata, buffer data. What? Weirdos. Buffer data, size, data usage, size, data, and then usage is GL dynamic read. Nope, still not working. I mean, I can always do the map thing. I just wanted to do it this way because it's easier, but if it's not going to work. Okay, let's turn on, if we're not, are we using the debug context still? I think we are. Yeah, we're using the synchronous debug context even. Or no, I think that installs the callback. That's what it's to. Debug context. What does to mean? Okay, debug context non-zero turns on that. Debug context turns on that. Greater than 1, yeah. Turns on debug output synchronous, which is supposed to force it to finish before it returns. Like it's supposed to, that's supposed to actually mean it blocks here until that finishes instead of overlapping. I wonder if that's not working anymore, if they broke that. So I mentioned at the start of the stream that I wasn't sure if I'd get tired because I didn't get much sleep last night. And here we are. I'm yawning. What am I missing? I could use glmap coherent bit. Did I put it back to the same spot? I put it to 15. Did I put the other one back to 15? Yes. Debug data of I don't know. I don't think I've ever actually done this before, so I don't think I have any other code I can go look at. I've read back images, but I don't think I've ever read back from a buffer before. Update buffer. Debug buffer 0 for debug data. Aha. Okay, so if we wait, well, let's do this. After we do that, let's do that. In fact, actually, let's do that. Okay. So if we get 999, that means it's successfully round tripped. If we get 444, it means it's not even being read at all. $999 means it's successfully round tripped. Yeah. It is storing that 999 to the buffer here. Oh. Do we need to actually put write only somewhere in here? Right, or write only, or I don't remember what's the syntax for this. No, because we're writing to these. We're writing to the output command lists. I guess write only doesn't belong to this. Maybe I have to put it inside. Oh, there we go. So 999. So it's like we're not writing to it. Oh, we're doing this after the... I have to do that before the... is the debug buffer? Where do we read the debug buffer? Oh no, we read the debug buffer. No, but we write it in here. Right, okay. Nine. All right, let's just to avoid any possible confusion, let's do this. Debug data 0 is 444. Unit 32 dummy equals 999 and update with the dummy. So we've never ever put the 999 into debug data ourselves. It's not that, but I just want the code to be absolutely unambiguous instead of reusing that same storage. Yeah. Okay, so we successfully write it here. We bind it, and this auto write to it. Oh no, this is use program meshify. So dumb. I need comments in this code. Like the fact that there's no comments in this code is so bad. That. Yeah. That. So first, this, let's put somewhere else to be unambiguous. Like inside this. Well, actually, this whole thing doesn't need to be indented. And then this is part of the color. Oh, so annoying. So now that I'm confident that that was why, I'm going to put this back to 831. I can't believe I just didn't even check which shader I was doing. $77s. All right, good. Let's take this read and put it back outside the loop. Yeah, so these command lists are 1, 2s, and 3s. Like there are 1s, 2, or 3 entries in the cult command lists. And so why it doesn't speed up more building with them, we don't really understand. But now we have the reads working. And the bug was just that I was setting the variable in the wrong place. Oh, so dumb. Binding the buffer in the wrong thing. All right, we're putting that down as a task. Comment the code for what each subsection does. If I said that, that would have been back in OBBG. But I don't know. That doesn't feel like something I would say. Oh, no, okay. If I said that, I think I would say it meaning not that this is a good thing, it's just why it happens. Not that it's the preferred scenario, just that the reason it ends up happening is because I'm explaining it instead of typing it. But it's bad. They do need to end up in the code. And I'm so yawny. I don't know. It's only been an hour. I hate to only stream for half an hour, plus half hour of overhead. So it was during OBPG, right? But now we have a tool that we can use to debug stuff in the future. And um, okay, well, let's talk about the breakdown. If you're tired, why fight it? Because it's totally possible that I could turn everything off, but go through the stream shutdown process and turn everything off and turn off all the lights and hop in bed and not be sleepy anymore. That happens to me. It might not happen this time. I have no way of knowing in advance. So, no, it's not boredom. This is sleepiness. Okay, but anyway, so okay, so then I wanted to add profiling. Oh no, okay, yeah, let's talk about the structure. Okay, so I talked before about this idea that how you can apply the parallelism of the GPU. There's lots of different strategies. This is Win 7 64-bit. I used 32-bit when I was doing OBBG. So the Voxel meshification is the following steps. 1, determine which voxels are solid with, what do we want to call it? Open, empty? What do I have a term for that already? With open neighbors. Determine which textures on visible voxels. Then we can build a data structure from which we can. Okay, this isn't the only way, but this is a general strategy from which we can read out which voxels are visible. Let's capitalize it so we know we're using the jargon word here. To build a list of visible voxels Determine textures when visible and which faces are visible. Determine textures on visible voxel faces and generate corresponding mesh. Okay. So let's give these steps names. Occupancy. Visibility. Meshify. Now we could break that into stages. No, I think there's no advantage to splitting that into two steps. We just would have each visible voxel generates 1 to 3 faces. So you could first generate the list of all the visible voxels and which faces and the textures on them, and then take that as input and now generate the faces. But that first step still requires an atomic list append, the same as the voxel faces do. So doing that, splitting that into two is probably always going to be pessimal. So I think this is, other than basically the approach we're doing right now, which is every voxel fully processes the command list and determines for itself whether it's visible. Every strategy that we have, I think, falls into this pattern, although some might skip step 2. So for occupancy, we can build an array of 256 by 256 by 1024 bytes. We could build 256 by 256 run lengths sets. Build an array of 256 by 256 by 1024 bits. So I talked a while back about how when I was talking about doing 8 by 8, breaking the grid down into 8 by 8 columns and doing computing 10 by 10, except not the corners, so it's 96, and that 96 doesn't divide by 64, but it does divide by 32. So maybe the optimal thing to do is to use a workgroup size of 32, have 32 SIMD lanes, process 96 columns for this occupancy bit step. However, on reflecting, the limiting factor here is going to be the usage of the shared memory to store the bit arrays. Like, they probably won't even go up to 1024. They might come down to 512 to keep their size reasonable. And oh, yeah, and so the GPU has a limited amount of shared memory. At one point it was 64K, or 64K was the most any one process could request. So let's say, what's the 2080? What architecture is that? Turing. Okay. Turing shared memory per core. So under CUDA, under CUDA, you can either have 64K of shared memory and 32K of L1 cache, or 32K of shared memory and 64 of L1 cache. Single thread block can access the 64K. So if we're doing 8 by 8 by 512, then that's 8 by 512 bytes, which is 4 kilobytes. So 4 kilobytes into 64 is 16. Is that right? And 16 might be enough for good occupancy. But so the point there is that if we only use 32 SIMD lanes, oh, I forgot that it's plus the extra, because it's 10 by 10. It will be specifying 10 by 10. So 10 by 10 by 1024 is 10 by 10 by 128 bytes. So 100. So that's 12 kilobytes. Wait. So when I said 4 kilobytes, I did the math wrong. Let's check that again. 8 times 8 times 1024 bits equals 8 times 1024 bytes equals 8 kilobytes. Yeah, so 12 kilobytes. So 12 kilobytes is going to use up 64 pretty fast. You're only going to get 4 or 5 of 12 kilobytes, which is why we might go down to 512 to make it better. But anyway, so the point is, if we only ran 32 threads, 32 lanes processing that data, then our occupancy, wait, which one is which? GPU occupancy versus utilization. Oh no, okay, it's utilization. Okay. Occupancy is whether the threads are, the SIMD lanes are active, I think. No, here they're using occupancy to mean SIMD. Oh no, occupancy. The capacity of the SIMD to high latency. So that won't matter how many lanes are active. All that matters is how many wavefronts. Yeah, because they're using SIMD, their way of meaning SIMD. Okay. So, yeah. So the point is that you might have pretty low occupancy because your occupancy is being limited by the shared memory. And so you might as well put more SIMD lanes to work on it because you're going to hit your occupancy limit because of the shared memory. So back when I said have the 96 columns be computed by 32 lanes, it'll be 64 lanes instead. So really 10 by 10 by 1024 bits, no corresponding memory. Visibility. So I think in practice, visibility is always going to be implemented as a second phase of but it has to parse the exact same data structure, so it's directly connected. Parse one of the above data structures and generate a list of visible voxels. Append then meshify for every visible voxel, traverse command list, or write out build 256 by 256 by 1024 32-bit Texel data write only, then read, then sparse read during meshification. So the idea here is that we're going to use this uniting data structure, the atomic append list of visible voxels and faces, to split meshification from occupancy, so that we can try different strategies for occupancy and different strategies for meshification, and we can solve those independently, and it should work whichever is optimal for each of them independently. We shouldn't need to try all combinations. Yeah, I think I'm too tired to actually write more code at this point. So questions, I'll bring that thing back up if people had questions about it. But it seems like most people are just hanging out and listening to me in the background rather than hanging on every word. Are there other approaches to this one? Do you often use the strategy of using plain text to solve a problem conceptually before writing the actual code, or is it only for the viewers watching? Yeah, for a problem like this, where I'm trying to think through the idea of these two things operating independently, yeah, I would definitely write this as text. I don't know if I would structure it this way exactly. Maybe. I would probably do it in comments in the code rather than in a separate document, but not always. Like, if we go back to 40M World, this is a project that predates the plan to stream here, and I made this document for the stream, which is just a list of all the things I need to do. But this is a pre-existing document. Oh, this is an updated version. Let's see if we go to the older version of it. Here we go. So here is a version of this, and you can see, like, this is this heavy design where I'm like thinking about what are all the pieces of data that it needs and how big are they, because this particular thing is trying to be size optimal because it's trying to store everything in the GPU without streaming. And so you can see me writing all this text, working through it. There's just, each of these is, I put the newest version at the top off my cut and pasting things. So you can see there's lots of thinking in text in this particular case. All right, last questions before we go. How would you accommodate a map much larger than your current design for flight sim use, made thousands of miles or whole earth spherical? Well, you just couldn't have the same level of detail, or it would have to be procedural detail, and you'd have to stream it. So like the actual project we're in here, rather than the one I just brought up, the project we're in here is an infinite city that is being procedure generated in chunks. In particular, you know, if for a Kerbal Space Program kind of thing where you like want to see a whole planet and be able to be close to it, that's an even more complicated problem, because you need to get the things be consistent. And you need different strategies at those different scales, and yet they have to be consistent. Whereas the infinite procedural city just has to be detailed at the city level. I don't have to worry about seeing it from space. Okay, last questions. Thank you for the VC6 Ultimate update. Yeah, this is working on the Voxel City, but I was just showing this thing about the only on GPU outdoor renderer, just to answer that other question. Yeah, the executable lock stuff is okay. Like, might be tolerable if it does let me use a more modern compiler. We are ending the stream. Because I'm too sleepy to stream. But what we were doing is working on, we added the debug output from shaders to CPU. Working on this infinite procedural Voxel City GPU compute. Okay, no more questions, so we're done. Thanks everybody for hanging out. I will see you next time.